My predecessor mentioned modularization is a requirement, and I can fully agree this is something that is really required to do more efficiency in hydrogen production, logistics, and of course as well utilization. My name is Guido König, and I'm the head of the industry management at SAMSON and as well responsible as segment manager for the sustainable industries. SAMSON, that's flow control, typically performed by modulating control valves and automated on-off valves. And to be honest, this is really a challenge due to the fact that control valves convert energy you have already put into the system into heat and noise. So how can control valves be efficient? This is the idea to do this with certain solutions, and I would like to introduce three offerings, three solutions for modularized systems to do more efficiency and safety in hydrogen production, in hydrogen supply, and as well on a special item, green hydrogen production by alkaline electrolyzers. First step is if you have a large-scale green hydrogen production, there could be an approach by combined clusters and a flexible operation of the water electrolyzer systems, which will combine different sizes and kind of electrolyzers as well as specific control of the hydrogen flow. As well, if we look to hydrogen supply options and solutions, then it is required to have an enhanced automation and a full integration of the control loop as well as the shut-off system, the overpressure protection in a fully integrated process equipment assembly, or let's call it a real module, a real skid setup. As well as mentioned, if we look to the alkaline electrolyzers, there's a certain approach to really consolidate all the required measurements of flow, pressures, and temperature into one single device and combine it in that device directly with a control offering. So it's a smart meter valve, let's say, that offers a lot of integrated functions that we can utilize to a more optimized operation of alkaline electrolyzers. But let me give a short introduction to SAMSON. What is SAMSON doing? 117 years old, more than 4,500 people in more than 60 countries with their own subsidiaries and with a distributed production. And as mentioned, the area is mainly on control valves, maybe not very attractive. So it's a field device handling the flow, but sometimes they are quite demanding conditions, and as well you have to be on the safe side, so as well utilized in safety loops. Hydrogen is not new to control valves due to the fact that it is utilized in the process industry since decades, and there are many solutions available how to handle hydrogen, especially in the gas phase, but as well now a growing sector as well as liquefied. The SAMSON approach is as well to support circular economy due to the fact that the products themselves are modular designed and allow that you can do service, spare parting, and as well adapting to other process conditions with an identical valve. So a flexible system that allows you to do optimized flow control in the different applications. Combined with digital solutions, so as well the main part of the control valves typically is steel-based in the pipeline. Now it's fully digitalized, offering communication, so data access to do full condition monitoring as well as predictive maintenance to get the optimum out of the control valve solution. Let's come back to the first step, efficient large-scale hydrogen production. Of course, if we look, you typically have fluctuating power supply due to renewable electricity production for the electrolyzers. As well, it could be, depending on the application and the setup, that there are additional resources available, like waste heat, so that you can utilize as well for the electrolyzers. The different types of electrolyzers, of course, have different characteristics regarding startup, regarding load flexibility, and so the idea is to combine different sizes of electrolyzers, different types of electrolyzers together as a cluster in order to do a very efficient and adaptable to the power supply production of hydrogen. In addition, it is required that you do something which was in the past not required due to constant powering of electrolyzers in the process industry. Now you have to do really partial load operation of the electrolyzers. And this can be performed by specialized control valves with a so-called high dynamic answer, and as well with a high rangeability, so that especially the hydrogen output can be controlled very precisely for all of the different partial load operation types of the different types of electrolyzers. If you combine both and do an advanced control strategy for the whole cluster, you can really realize a very adaptive, large hydrogen production utilizing the different types and sizes of the electrolyzers, as well as controlling the partial load operation efficiently. But if you do so, and you do as well an operation together with specific startup and shutting off several of the electrolyzers in the cluster, it is required to have a very good backflow prevention solution for the hydrogen produced. And this is as well a solution of flow control, which can be realized self-operated or as well fully digitalized. Another step is, if we do more and more hydrogen supply and hydrogen utilization, then of course it's required as well that you can operate a full range. So starting from blending hydrogen into a system up to full hydrogen operation. So within the storage of the hydrogen, you will have different pressures. So there's shifting. And as well, it is required to have a very precise output pressure for the utilization. Just to give you an example how this can be realized utilizing different control valves. Here you have an example of a 50 bar outlet where you have 55 to 200 bar inlet pressure and a flow rate turn-in ratio bigger than 250. So really do split range operation do local control, and as well combine that with an efficient overpressure protection with an integral double block and bleed. Coming back to hydrogen production by alkaline electrolyzers, there you have several requirements, but as well one very specific one is that the concentration of the KOH is a critical process parameter. As well, by splitting the water into hydrogen and oxygen, you need precise water feed control. And as well, the electrolyte circuit has to have a good temperature distribution to be very efficient. The traditional setup to do this kind of control is that you have sensors, control valves, and combine that together connected to a PLC or DCS. The SAMSON approach is now to integrate all that into one single device. So to do the flow measurement, temperature and pressure measurement inside the control valve body, as well with the flow meter and all the sensors together measure very precisely the KOH concentration. So this allows a very reliable, accurate, and stable flow control. This is a new approach really to combine sensing and flow control into one final control element. And this is something what we show as well at our booth, and you are invited to have a look on it. Finally, a modular system approach gives you really benefits, because with these process equipment assemblies as kit, you can really highly standardize the setup. As well, you have a reduction of complexity, cost, and installation effort, especially if you combine all the different elements into one single field device. You can have optimized performance due to the built-in module automation, so the setups can really be directly automated and integrated into the system by the so-called module type package, so a standardized description to integrate into the process orchestration layer. So it's really plug and produce, so that enables that you can integrate the modules quite fast and easily. And this setup gives you much more flexibility as well as scalability, due to the fact that as well it's not just the option to do higher or larger modules, but you can do a numbering up approach with these standard module setups as well. Thank you very much. There's a little bit time left, so if you have any questions, please feel free to do so.